Okay, so now before we go and make the determination of which one of these vectors is striking a building or getting through as a complete view, I'd like to just take and group all of these items just for good housekeeping, ability to go back and look at this and understand what we've written. I'm going to create that into a group, and I'll call those view vectors. And that'll just help us keep organized when we go back and look at this. And so we have all of these views, but we don't have any determination yet about this idea of intersection. So let's see if I'm going to just right click and I'm going to go intersect and see if we can find something. And actually this will pop up right away, does intersect. So if I click on it, it goes geometry does intersect, and we can input two pieces of geometry. And our two pieces of geometry are the line and the buildings. And the buildings are still way back here. So here's all of the inputs of all the solids. We grouped them together, we flattened them, made them into a single unit, and I have them here in a watch box, but we'll just continue out from that. And we'll put it in there, and we'll go ahead and run it. And what we'll get out of this is a list of trues and false. So it's either true it intersects or false it doesn't intersect. And it's a list of lists, if you'll notice, so I want to flatten that right away. Now if we look at this list, I don't know if that'll run. It won't. Got it on manual right now. Now we have just one single list of trues and falses. And that means that it's either hitting a building or not hitting a building. So the falses are actually the ones that are good views for us. True means it's hitting a building, it's blocking our view. So let's try to make some kind of a determination about how we can use that. And I'm going to try what's called a Boolean mask. So I'm going to do a list filter. And it's by Boolean mask, Boolean being logic. So the list is these vectors, which are over here. And the mask is the Boolean logic. So now if I run that, we'll just get a list of lines that aren't hitting anything or hitting something. There's two lists there. So the ins and the outs, the ones that made it as true probably, and the ones that didn't make it that are false. So let's just visualize right now. So what I want to do is I'm going to hide all of our lines, which means I have to turn the previews off of a lot of these. And then we're going to assign a value to the output. So I'm going to grab this and I'm just going to copy it. It's not really level in color right now, but it's line in color. And I'll feed in the out geometry. And we'll go ahead and run that. And it's not got a visualization, that's why I'm not seeing it here. There we go. So now what we're seeing is, if I was to zoom in here, should be, this might be everything that's striking a building. So let's put the other one in. And run it. And I'll try to zoom in on that geometry and rotate it a little bit here. So it actually looks like not all of these vectors are hitting and some of them aren't. So I've got to go back and figure out what's wrong there. Hold on. Okay, so I took a second to figure out what was wrong, and my list filter by Boolean mask was being fed a list, two different lists. One of them wasn't flattened. So this list has a list of lists. So I went ahead and flattened it also. If I probably left this one unflattened, it probably would have functioned fine. So what we are getting out of this now, and I put a couple of watch boxes in, is we have the trues and the falses separated out, and those add up to our total values that we would have. I'll just get rid of these for clarity right now. And what we have on the screen now are all the views that are getting through that I've added color for. And I'll say, let's rename this. I'll double click it. And this is really, a lot of this I'm going to delete in a minute. Views. And now we'll make a duplicate of this. Oops, not the way to do it. It's C and then V. And we'll call this no views. And we'll make this, instead of red and green, we'll just make it red, or a yellow value, excuse me. And we'll use the, this time we'll use the out values, and we'll go ahead and run that. And now we have a mixture, and maybe this will, if you try this out, this will give you a little clarity about what's going on logically here. Let me rotate this a little bit. So now you can see wherever we're piercing through and have a complete view, we have yellow. Wherever it intersects the building, we have red lines. So now we have a way of determining which floors would actually have more views associated with them. And obviously as we go higher and as we move around the site, because our building, when we go to do generative design, we're going to move this building all the way around the site to simulate different locations. So, but every time it's going to do this same calculation for us. And our goal here is to find out, is to maximize the amount of yellow over the amount of red. So once again, that's enough of probably for this section. We have now taken, just to review, we've taken our view vectors and we have intersected them with our buildings, which is way back here. I'm sorry to have to drag this all the way over. In a does intersect calculation, we're flattening that one, we're flattening this one, and then we're using what's called a Boolean filter for all of the lines that are coming in here to be filtered by whether in fact they do or do not intersect. So now we have a way of separating the views from the no views. And we can now take the views and assign and maximize that value in order to come up with the best location and height for the building. And we'll start to look at that in the next section. And this turns into a hand. This is kind of a glitch. If at any point you click over, I don't know if this will happen in your Dynamo, if you ever click over something to enter it, it'll turn it back to the arrow for you. And I don't know why it does that. So, okay, so we'll pick up on adding some values to this. Then we can start to look at this idea of optimizing our design.